video, we're going to prove an identity in which we have to transform the left side into the right side. So we're given the left side as two fractions, one subtracted from the other, and we have to show that this left side is equal to the simplified version of the non-fractional representation of showing that minus cosine x minus 1. So what I'm going to try to do, I'm going to try to achieve the same denominator here. Okay, so basically I'm going to try to get the denominator of the left fraction being the same as the denominator of the second fraction. So we're going to try to make sure that this fraction denominator shows 1 minus cosine x. And then we can combine the two fractions and simplify it in the best way possible to arrive at this final conclusion. All right, so first I'm going to take the given first fraction, and I'm going to use the conjugate of the bottom. So the conjugate of the bottom means that I'm going to have secant x plus 1. So instead of the minus, everything else is the same. Instead of the minus, I'm going to have a plus. And whatever you do to the denominator, you have to do the same thing to the numerator, because every fraction numerator and denominator is multiplied by 1, right? So whatever you do on the bottom, you have to do the same thing to the top. Now, we're not going to touch the second fraction just yet, because we want to get first the same denominator as the second fraction's denominator in the first fraction. Right, so we're going to just copy that as we work the first fraction. Okay, so I'm going to use a few formulas here that are going to be handy. First, we'll notice that you know that secant x is equal to 1 over cosine of x, right? That's an important identity. So what this means that if I try to distribute the cosine times the secant, that means if you solve for the 1 here, you'll know that cosine x times secant x is equal to 1, right? Because 1 over cosine is the reciprocal, basically, of the secant. Okay, secant is the 1 divided by the cosine, right? And cosine x is 1 divided by secant. So when you multiply these two together, you get the product of 1. So that means if I try to distribute that, I'm just going to show the distribution first. All right, plus cosine x, of course, on the top, divided by, and here it's very important. Notice that using the FOIL method, why is the conjugate powerful? Because in this way, the reason why I'm using the conjugate is that I know that my goal is to get the last product -1. In the first product, secant square x. And the middle two terms using the FOIL method will go away because of the plus and the minus. Right? So basically what I'm getting is secant square x minus 1. And we know secant square x minus 1 is precisely equal to tan square x. Right? That's another identity. Again, copying the second fraction. We're not doing anything to it just yet. Okay, so now we can distribute the cosine and the secant. We know that the product of that is going to be 1, like we said. So it's going to be 1 plus cosine x divided by, now we're going to replace the secant squared minus 1 with a tan square x. All right, tan square x, and then copying the second fraction. Again, we're not touching it. So now, as you can see, we're still trying to get the bottom to show 1 minus cosine x. So what are you going to do now? Notice that, again, I can use the conjugate using the top expression, right? So I can write 1 plus cosine x and then use the conjugate, basically multiplying this by 1 minus cosine x, okay? So that means the bottom also receives 1 minus cosine. 1 minus cosine multiplies the tan squared, right? Tan squared x. And again, copying that. Now notice we're getting close, right? Because 1 minus cosine is already visible. That's what we're trying to show, right? We're trying to get this denominator, tan squared x, into the 1 minus cosine. That's already good news. You can already see 1 minus cosine shining right there. We just need to get rid of this tan squared. Right, so copying this down, the second fraction, we're not touching it. So what are we going to have? Notice that this is another formula that we can use. Again, I noticed that I can use 1 plus cosine, the conjugate 1 minus cosine, because the product is going to be 1 minus cosine squared. And again, because the first product is a positive one, the middle two terms go away, they become 0, and then the last product using the FOIL is going to be negative cosine squared. Right, so what this gives me is 1 minus cosine squared x over tan squared x times 1 minus cosine. All right, copying the second fraction. Now, what does this give me? Notice that 1 minus cosine squared x is equal to sine squared x. That's another identity that we can replace the numerator with, right? So sine squared x on the top divided by tan squared x times 1 minus cosine, all right? Then copying the second fraction. Let's see, so now what's going to happen? Notice that tan squared x is equal to sine squared x divided by cosine squared x. That's another identity that you should know. Tangent is usually just sine divided by cosine, so when you square the tan, you're just squaring each of these, right? Sine squared and then cosine squared. So basically, you can already see that the sine squared x will be canceled out if you replace the tan squared x with that, right? The sine squared will cancel out with this top. And that's exactly what we wanted, right? So basically what happens is we get sine squared x divided by the quotient of that we replace the tan squared x with, right? The quotient times 1 minus cosine x. And then copying this down, the second fraction, we're not touching it. All right, so now what are we going to have? Again, notice that the tan squared x, the sine squared x cancels out, and the cosine squared x was the fraction, was the denominator of a large denominator, which means that the cosine squared will take the place of that big numerator there, right? So cosine squared x goes on the top of this big fraction, right? And then on the bottom you have nothing else but 1 minus cosine. And look at this. Now we achieved the same denominator, right? That's what we wanted to do. The same denominator, 1 minus cosine x. So that means I can go ahead and just write cosine squared minus 1 over 1 minus cosine x. Okay, getting better. Now we have a single fraction, but we still need to arrive at this conclusion, right? So that means we cannot afford to have any fractions remaining. So now you might probably tell that you can use the conjugate one more time. So what I'm going to do now, I'm going to replace the 1 with this identity, sine squared x plus cosine squared x is equal to 1, right? That's coming from the rewriting of this identity, right? Because if you add cosine squared x to both sides, you will get sine squared x plus cosine squared x on one side and 1 on the other side. So basically what I want to replace this 1 here, substitute it with the sine squared x plus cosine squared x, right? So I'm going to have sine squared x plus cosine squared x. And why am I doing this? I think it's a great idea to do this because I will cancel out the cosine squared, right? It will be subtracted from itself, as you can see, because the minus distributes to the cosine squared, right? So cosine squared minus cosine squared, that's going to be 0. So the only thing that remains is going to be minus sine squared x, all right, divided by 1 minus cosine. And that's beautiful, right? Because now I know that if I use the conjugate of the bottom 1 plus cosine, I will get 1 minus cosine squared ultimately, right? And that's equal to sine squared, which we already have at the top. So that will cancel out ultimately, right? So let's try that. Let's see what happens. So we can put the minus in the middle. And let's use the conjugate of the bottom, which is 1 plus cosine x. All right, so on the bottom, we're going to have 1 minus cosine x, 1 plus cosine x. All right, so keeping the minus in the middle, so now we can distribute. No, let's not distribute this. Let's actually leave that alone for now. Let's have sine squared x, and on the bottom, I'm going to have, and also not to forget, 1 plus cosine x, and on the bottom, I'm going to have 1 minus cosine squared, right? And now we can use this identity, which is equal to sine squared x at the bottom. So we're going to have this 1 plus cosine over sine squared. Now the beautiful thing about it, sine squared cancels out, right? So that's going to be equal to no fraction anymore, right? The minus is in the front, not to forget, the minus in the parentheses, 1 plus cosine x. So now if you distribute the minus, you will arrive precisely at the -1 minus cosine x, which is absolutely the same as the commutative property of subtraction or addition, right? Minus cosine x minus 1. So you arrived successfully at the final expression, which is as simplified as it gets in regards to the given expression with two fractions. You've proved this identity successfully. It wasn't a lot of, it was a lot of steps, but you now know how to use these identities in this rather intricate problem. I hope you've enjoyed this tutorial. Thanks for watching. See you in my other videos.